My name is Olin, and I'm from the College Preparatory School, and my project is the real-time planet tracker, and I'm on my second milestone. So I chose this project because I'm interested in astronomy, and I wanted to know where to look for, where the planets are when I see through my telescope. So currently, for my second milestone, I focused on the software, the coding component of my planet tracker, so my Arduino board can tell the servos exactly where to look in the sky. But however, I still had a few hardware updates, and the most important one, as you can see, is I have a new servo system, and I replaced the old servo system in milestone 1 because uh, those servos only could go 180 degrees, which is fine for the top tilt servo, but is actually not fine for the bottom pan servo because I need a 360-degree motion in order to see the whole celestial sphere. So with this new servo, I can has the capability of going turning over 1,000 degrees in total, which is a lot more than 360, which is good for the functionality. But however, I had to code it so that I had to limit the range of the servo so it doesn't go to, spin too many times and cause the wires to tangle. So I had to manually test the different pulses of the servo, which the pulse is essentially just the kind of the positioning of the servo. So it's just a different pulse number corresponds to a different position. So I just had to limit the range of those pulse values, and then that's how I got my 360-degree motion. And another thing that I kind of changed is this IMU here, because the IMU, when I was going through my code, like the when I used the potentiometer to switch between different planets, the servos did respond to the different selections, but however, the numbers that they were outputting were incorrect. And the reason for this, or at least partially, was because the IMU isn't actually a compass. It just kind of measures the positioning, an orientation. So since it's not exactly a compass, and also because there's a lot of magnetic interference from all these electronic parts, uh, it wasn't working in the way I intended to, and it was just kind of another factor among many others that was causing problems during my debugging process. So I just chose to temporarily remove it for this milestone, and but that does come with the caveat of now, since without magnetic calibration, my servo system must be pointed north uh, when I'm using it, which I have done right here so that so I can do this demonstration. So on to the coding part, which right now the tracking mode is fully functional, and I can right now I'm getting serial output data for the planet Mercury right now. So as you can see, the most okay, this thing disconnected, but hopefully it will uh, reconnect shortly. But as you can see here, at least for the last second here, we have our most important coordinates here are the azimuth and altitude, which are 88.22 and 34.71 respectively. And let's see, we can compare to a reliable astronomical database, which we can update just to get accurate data. And as you can see, the azimuth here is 88.4 and the altitude is 34.8, which is pretty accurate to the results that I got from my planet tracker. So as you can see, that is proof that it works. And hopefully if this disconnects or it reconnects, I can show a different planet. Okay, now it's reconnected, and I can go to, let's test Pluto, which has 260, our azimuth is 264 around, and then our altitude is negative 32.58, which is pretty accurate to the database again, which has 264.3 and negative 32.5 for the azimuth and altitude respectively. So again, we can see that this my calculations are fairly accurate up to a around 0.5 degrees error, which is pretty acceptable for these kind of I made a lot of some approximations in the calculations. So I'm pretty satisfied with these results. But however, when I was testing my trajectory mode, uh, which kind of I can use instead of using the potentiometer to switch planets, it's kind of tracking how much time I'm setting how much time in the future or in the past I want to look at. And that the results of that were okay, but had more error than the tracking mode, which was like the error was around maybe like up to 5 degrees versus like 0.5. So that's a whole like order of magnitude, and 5 degrees is pretty significant, like if you're just looking as compared to 0.5. So I will have to, going into milestone 3, I will have to take a look at that and like see like how, like what the calculations are doing. And also for milestone 3, I will be kind of like CADing a whole like box to put all of these components in, so like the wires aren't like all loose and stuff. And I will figure out a like permanent kind of more permanent or like positioning for this laser right here. Right now it's taped, which like the taping is pretty good and it works, but going to milestone 3, I will need to figure out like maybe like hot gluing or like finding like a better adhesive. And that concludes my video.